Alrighty, in this video, we are going to talk about cotangent. If you clicked on this video first without any knowledge of tangent functions, be sure to watch the video on tangent functions first before attempting cotangent, because they are very similar, and I'm going to go faster in this part because we should know the basics of the tangent function. So we know that with cotangent, our coordinate plane form of cotangent is x over y, meaning that if y is equal to 0, then that's where we have an undefined value. You're going to see that our undefined values are at 0, pi, 2 pi, negative pi, negative 2 pi. So more specifically, 0 and pi, which makes sense because at 0 and at pi, oops, y is 0, and we don't like that. The period is still the same, and that's going to be pi over b. And because my asymptotes are multiples of pi, this just tells me that my asymptotes are going to be multiples of pi over b. Unlike pi over 2b, because for tangents, my asymptotes are every 2 pi. No, not every 2 pi, every pi over 2. You guys can read 1 through 5. It's the same thing that we did with tangents. So hopefully you got that. You'll also see here that cotangents, oh, I should probably give you another different graph for this one. Cotangent, very similar to tangent, except we're starting high first and then going low. All right. But first, let's do a little review on negative tangent, and then how does that compare to positive cotangent. We did a very similar problem on the tangent video where it was just tangent, but now this one is negative tangent. My period is pi over b, or pi over 1. I have a phase shift of minus pi over 2. Now, because this is a tangent, my asymptotes are in the form of pi over 2b or pi over 2, which means that my asymptotes here are at 0. And then I'm going to go every pi. I have a midline of 0. And then I have an a value of 1. I'm going to pick a point. And then because it is negative, I'm going to go high first. And then low. That's the little TODR review on tangent. Okay, so let's see how that compares to cotangent. If I have a period of, same thing, pi over b, which is just pi. I have a phase shift of negative pi over 2. And here's the thing. My asymptotes are in the form of pi over b, which is essentially whatever your period is. My period is pi, so I'm going to subtract pi and pi over 2, which gives me pi over 2. This pi over 2 tells me that I have an asymptote of pi over 2, and then I'm going to add pi. And that's going to give me my asymptotes. Okay, my midline is at y is equal to 0, and then my a value is 1. So I'm going to start at pi. I'm going to go up and left, and then right and down. Then I am just going to graph it. Of course, making sure that it is pretty as possible. Not bad. Actually did decent for once. Now, you might ask yourself, OMG, Mr. K, they look the same. Yes, they look the same. However, notice that your asymptotes are completely different. So just make note of your asymptotes because I will be checking that very closely whenever you graph cotangent and tangent on the test. Okay, 14 says 2 cotangent of 1/2 x plus pi over 2 minus 1. And I have a period of pi over 1/2 or 2 pi. And remember that my phase shift is left pi over 2. And then my asymptotes are in the form of pi over b, which is essentially the same thing as my period, or 2 pi. Which means that 3 pi over 2 would represent my starting point of my asymptote. Then I'm just going to subtract 2 pi. And then start graphing. Midline's at -1. Then 1, 2, 3, 4. I have an a value of 2. 1, 2. 1, 2. And remember how I got these points right here is because I'm taking the midpoint of the section between my midpoint and my asymptote, midpoint and my asymptote. This one, since they aren't close to each other, I think my graph is not going to look pretty. Yeah, not pretty at all. Okay, so now we have 15. Oh, 14's wrong. Sorry. Let me change that. It should have been the other way around because it is cotangent. That's embarrassing. I knew something was wrong. Ah. Let's see. Oop. That's kind of better. Not the best, though. Okay, sorry about that. That's embarrassing. Can't forget about that. Okay, so I'm not gonna forget about that on number 15 though. 15, same thing where I have a half as my b value. And then my asymptote, I'm just gonna add pi over 4. 8, so that's 9 pi over 4. Your midline's at 2, and then your a value is at 1. Lucky for me, I already have 9 pi over 4. That's like literally at the end. And then you have your 2 pi. So right here. 8, right here. Okay, your midline's at 2. And then I'm gonna find my midpoint, which is right here. I'm not gonna be a clown, and I'm gonna go up first. Then I'm gonna go down. Same thing here. 1, 2, 3, 4. And then we're just gonna pray that, okay. That one wasn't that bad. That one wasn't bad either. There's your cotangent function for number 15. Isn't that pretty? All right, so that's your little summary on graphing cotangents. In the next video, we are going to talk about cosecant and secant and how they are very, very, very similar to sine and cosine. So this is going to be a lot of fun.